Hey guys, welcome back to the next video. In this video, we are going to talk about the service. Now, you must have seen the previous video where we have talked about the architecture of all the load balancing service, which we're going to configure right now. So we will do the hands-on for the same. So as you can see over here, we just need a file. We just need some deployment going on. So I'm going to pull up the Sterling RU deployment or FU deployment, whichever you want, you can do that. And only thing you need to do is like you need to make sure that you go to version 1 of it so that we can actually have the load balancing setup work for it or set it up correctly. So once I have this version 1 set it up, as you can see, I'm on version 1 both on the image as well as on the version 1 as well. So I'm good to proceed with this one. So all I have to do is like coup control apply -F, and then I'm just going to give this YAML file. It's going to create some pods. It's going to create a RSS file. So once I have done that, I can actually create another file, YAML file over here, which is going to be the service for controlling this pods right now. So this service is going to route my I'm going to have one cluster URL, and I can use the port number, the host port number, which is defined by default to control or to access these pods. Okay, so rather than accessing one pod, one IP address to one pod, I can use the cluster IP address or the node port on the local IP address of my server. And I can actually log into multiple systems, any of this system. Okay, so that's the major use of this. And then when I upgrade it, I don't have to worry about it, because when I upgrade it to the version 2, it's going to give me new IP address, but I am not worried about this because this is going to cover me. Service load balancer is going to cover me because the selector is going to look for the environment name, the app name, and the server name, server equal to web. So these are the only things which needs to be taken care of. Here I've given PROD. I'll make sure that this is PROD. Okay, I've changed it all to PROD because I want it to reflect in the similar format. So I copy paste the content from the GitHub page and just put it over here. And this should have the details here. App API version, the service is in like kind. And then the name of this service is going to be Sterling LB-prod-SVC service. This is short form is SVC for service. And then you have the selector here. So this is going to be very important for us because every time a pod is created and it uses these three of the labels, then it's going to map to this particular service. So you need to be very careful. So it needs to be the Sterling, production, and web. So there could be one combinations only for this. So that's why we are mentioning this. We're not giving any versions here because we're not restricting ourselves to a specific version. So that's why the version is not here as part of the selector. If you're going to give versions, you're going to lock yourself in a specific version, and then when you update or upgrade your application or your deployment to the next version 2, you kind of this kind of gets destroyed because it's looking for version 1, but you are actually in version 2. So don't lock yourself in version. So that's why the version is not part of the selector. Here in the port, you have the TCP protocol, which uses 80 port number for it. The Sterling service is running on 80 protocol. 80 port number. And then the target port is 80 port number, where the containers is listening on 80 port number. So you have to change the port number here based on the container which it is running. And then here is the type load balancer. Here the load balancer is basically the service type over here. So save and quit this file. You could run this file using kubectl apply -F. This is going to create a service right now. So kubectl get SVC. This is not the first service we are creating. It's there's a default service by Kubernetes, which is already we are using. So you can see that this you can ignore because this is some test service I've created. So I will just delete this. Sorry about that. Delete SVC and then the service name. All right. So now You can ignore that now. So now this service right now is created with the type of load balancer. You can see that there's another service called cluster IP address. So that's another one. And then this is a load balancing service, which is created on this port number 10.98.72.222. Now this would not have access from my local system. So if I just try this one, and then I think you won't have access to it. So it's just like it's not working. Colon 313. This is the port number. I need to try this on. So let's see if this works. No, it won't work because this is an IP address which can only work within this system. Okay. So it won't work. But what you can actually do, you can use this IP address which you're connected from your Windows system to this server, right? You can use that with a combination of this host port number because we have now the host port number on the servers. So all these three servers like manager 1, worker 1, worker 2 will all have this host port number listening on them because the service is distributed across all entities. So it is not just the manager, worker 1. It's like all of it will be involved. So you can use this to invoke those things. We will check that one after after some time. Now, what I want to show you is when I access this IP address, which of this container will be used. That's what I want to show you because that's very important because that's one of the whole core concepts of having a load balancing service, right? So now what I'm going to do is like for this example, I'm going to use the curl command over here with the IP address over here. So let's see if the AD works fine here. So you can see that Nginx version 1 is coming when I use this. Now, from which pod did this message come from? That's a very good question, right? Now you got a response, but who sent this response? Like who from here has sent this response? That's a good question. So when you do the kube logs and then you put the Kubernetes item over here, so there are these 3 nodes which is running. So let's just verify it. So I'll verify one from here, one from here. So let's just do the same command. Just bear with me. So here, rather than watch, I'm just executing this command. So here I will just put kube log on all 3 systems. And then I'll give the second one over here. This is already first one is given over here. So third one, I'm sorry, I pasted it here. First one, second one is over here, third one is over here. When I do a kube log, right, you can see that, oopsie. Okay, so the thing is that you cannot do this log thing from the node, like the worker node. You can only do it from the master node. So I'm just gonna do this, both this from here. All right, so just... All right, so you can see that it has come from third. So how I'm saying that, so if you see the previous one output, right, over here, this is one. Okay, so this is where it says start worker, right? So it didn't come from here. It came from this node, the third node, the mpdq. So that's the last command I executed, mpdq dhq. So that has actually, got the request. So let's run it again, see what happens now. Who has got this request? So first, let's check the mp1q if it has got it. No, it has only one request. So let's check the other one, jd6f. Okay, jd6f has got the second request. Let's try third request now. So obviously, it must have gone over here, but no, it didn't come over here. Let's see where it went. It went to MP. So let's try that again. No, it has not come here. It has gone to JD again. So let's just try hitting it randomly multiple times. At least one time it should go to the server. Yeah, so you can see that 2 times it went over here. So which means that there is a load balancing in place. and that is distributing the traffic accordingly. I would say that why a lot of traffic didn't go to this 2JJ V8, because 2JJ V8 has been hosted with the JD6 on worker 1. So it identifies that the worker 1 has 2 servers hosted and the worker 2 has only one server hosted. So it wants to split the request equally, not to pods, but to the host. So which means that the nodes will get the proper number of request directions when compared with the pods. On a total request of 100 requests, it wants to spread 50 requests to worker 1 and 50 requests to worker 2. In most of the cases, the worker 1 here will get like 20 requests and another 30 requests will go over to worker 1 over here because it's the same node. So the CPU memory is all shared between these, these two nodes which is running over there. So it doesn't make any sense for you if it is 100 requests, total requests, or 50 requests. Here it can go 30 requests, here it goes 20 requests. That makes sense. 25 makes sense. 30 and 20 also makes sense. Or 10 and 40 also makes sense because it's the same host. It doesn't matter how many requests goes to worker 1 because it is on the same host. So either it goes over to this pod or this pod, the same kind of CPU and memory is going to have the same implication because it's hosted on the same node. And in worker 2, if it divides that other 50 requests to worker 2, that makes complete sense because it is a different host which may have a different CPU and memory assigned to that worker host. So likewise, the load balancing works perfectly fine, and that's the basic thing of having this service created. Now you don't have to worry about upgrading to the newer version because if I go ahead and apply this newer version of my service over here, so version 2 here, then I do apply of this particular one. You can see a newer versions are getting created, but my IP address here remains the same. You can see that version 2 has come. My IP address remains the same. I have not changed the IP address, but it is getting items or updates from the newer IP address, which is getting assigned over here. So irrespective of what IP address changes, which happens on the back end, your load balancer settings wouldn't change because it is the service which is on top of your pods, and it's going to be lying on top of everything else so that it will have a good justification for you to work with. So you can see that it is going to be on top of everything else, wherein which the endpoint will change, but the items inside this will not change. So for example, if you can see that Q control get endpoints EP, you can type endpoints or EP, that's much better. So you can see that the EP has changed to 138, 130 and 131. So you can see that the EP has changed. It's been 9 minutes since the change, because what it monitors is that it monitors these endpoints rather than anything else, because that's the one which it requires to route the request to. So that's basically what it does. So when you see the get SBC, get it SBC in detail, describe, you can actually get this one, and you can see the endpoint definition over here and the port number which is being used over here, node port number, target port number, and all these other settings over here. So this is pretty much what I want to show you guys before we go ahead and close this session. I hope it was useful for you to understand. Your review means everything to me. And if you have any questions, please leave your questions on the question section. Thanks again.